Hi everyone, this is Zoltan and come back to my radio workshop. Okay, I know that basically I am dealing with military Russian radios, but now it came around Drake transmitter, because this is the transmitter device, to fix it for a friend of mine. And this device is so unusual for me that once I figured it out how it's working, I have decided to make a little video about it. Sorry for my English. This is my first English video. Basically, I'm a Hungarian guy. I am doing my best to speak as well English as I can, but let's see. So, the Drake T4XC transmitter. This is a shortwave transmitter. By the book it says that it has a 200 watts output. In my case, the finer tubes were quite huge, so I could get only about 40 watts from the radio, but basically it was working. Okay, so let's see how it's creating the output, the frequency of the output signal. All the way, it's using a so-called down mixing, so it's subtracting one frequency from the other one. So the main signal frequency is made up from three parts. First, we have here a main crystal oscillator. This is a fixed frequency. It equals always the setting of the band plus 11.1 megahertz. The second one is the VFO, as we used to call VFO. In this case is called permeability tuned oscillator, because it's the tuning of this oscillator. It's not done by changing a variable capacitor as it usually used to be, but changing the ferrite core of the coils, and thus altering the frequency from 5.455 megahertz back and forth down to 4.955 megahertz. This radio always uses 500 kilohertz from the start of the band. So you can see here that the difference, it's exactly 500 kilohertz. And the third oscillator that is used is the carrier oscillator, that basically it has a fixed frequency of 5.645 megahertz, and this frequency is altered by X, done by the balance modulator. In this balance modulator, basically it's created the sound that you are going to hear on the other side in the receiver. In SSB and AM mode, this X is basically the sound coming from the microphone. In CV Morse mode, it's a fixed frequency of 750 Hertz. But because we are dealing only until 1 kilohertz, so in our example, we are going to ignore it. Okay, so let's take an example. The desired output signal frequency is exactly 7 megahertz. How is this put together in this radio? The band is set to 7 megahertz. Mode is set to CV, that it means that the balance modulator alteration or deviation will be exactly 750 Hertz. That it's quite difficult to set, but it can be set. I will show you later. The VFO is set to 0 because we want to transmit at exactly 7 MHz. So the frequency of the VFO, theoretically, it's 5.455 MHz. The main oscillator, as I told you before, it's higher with 11.1 MHz than the base frequency. So in our case, it's 18.1 MHz. The creation of the output frequency is made in 2 steps. The first is premixing. It takes the frequency of the main oscillator, subtracting the status, the frequency of the VFO, and thus it creates this frequency in our case. This frequency is called the injection frequency. And the second step for the final mixing, or how it's called intermediate frequency mixing, it takes the injection frequency that was created here and subtracts the carrier frequency. And at the end, it comes out the output signal frequency. So you see, it's done in 2 steps. In my opinion, a little bit quite complicated way. The 7 most important circuits responsible for creating the output signal are the followings. Main crystal oscillator made with transistor Q7. The VFO, also made with 2 transistors Q6 and Q5. The premixer tube V8, that is creating the injection frequency. Then it comes the carrier oscillator made up from transistor Q1, Q2, and Q3. This is feeding the balance modulator, and in the balance modulator, this carrier frequency is deviated or altered, or with 750 MHz in the case of CV, or by the signal coming from the microphone in case of SSB and AM modulation. The intermediate, it calls the intermediate frequency, in my opinion, final mixer made of 2 V3. And at the exit of this tube, we already have the final frequency that is fed to the finally tube's driver V4. Okay, so let's see these circuits in real. Here is the schematic of this radio. So let's take the main crystal oscillator is this one. This one. Here you see the crystals installed in the radio, and this is the main oscillator. The second one is the VFO, is this one, made of Q5 and Q6, Q5 and Q6. Then it comes the premixer tube. The premixer tube is this one. At the end of this, at the exit of this, okay, there are 2 filters, but we got the injection frequency. Now, let's go back. Then we have the carrier oscillator. Carrier oscillator is made up of 3 transistors. They are here. And this little device is the balance modulator. The balance modulator is altering or deviating the frequency of the carrier oscillator, as I told you, or coming from the sound from the microphone, or with a fixed voltage that it should produce a deviation of 750 Hertz in case of CV. This is the amplifier, this is a filter, and this is the final mixer or the intermediate fixer tube. I'll show you a little bit more detailed. This one, this tube, and at the exit of this tube, we have a filter, and you can see this one is the driver tube. So this is how it makes the output, the frequency of the output signal. Quite unusual way in my opinion. Okay, in the next video I am going to show you in the radio exactly where are they, these electronic circuits. Okay, see you in the next video.